Welcome to a little bit of Northern California winter in this room. I hope you guys got a chance to stand up and actually warm up a little. I'm Mitch Sulaski from Workday, and I'm up here with my colleagues from Lyft, Nicolas Flacco and Henry Yang. We're here to talk about the evolution of Envoy as a dynamic Redis proxy. I have the easy part, tell you about what we're going to actually talk about in this talk. First, we're going to start out with a little bit about why Envoy. And then Henry's going to jump into the actual evolution of Redis support, and we'll show you some of the deeper internals of what's going on. And then Nico's going to actually cover online data migration and as a real production use case. And then we'll end up a little bit with what's next, and hopefully we'll have time for Q&A. So why Envoy? Using Envoy actually provides us with a really nice set of advantages. One of the things that Envoy allows us to do is support complex behavior that we want to implement in the proxy and relieve the Redis client from actually having to implement or do correctly. And this actually helps quite a bit. And like I said, we can support very complex operational environments. We can handle dynamic configuration changes. We can implement smart read policies. We can federate over multiple clusters using things like prefix routing. And then we can do zero code change online data migrations, all just by using a Envoy as a single control point. Of course, as you've heard from all the talks earlier today, we also get consistent observability, which also helps quite a bit in any sort of operational environment. And I'd also like to point out that really what Envoy provides that we find at Workday very useful and folks at Lyft feel very useful is that it's flexible. It's flexible and it's flexible. You can deploy in any sort of environment, which is really important in sort of complex environments where you're moving, say, from, a self-hosted private cloud implementation of your own set of jury-rigged protocols and products to something like Kubernetes. And lastly, performance. Envoy's worker thread architecture and the ability to do Redis pipelining and a variety of other things, the focus on performance is baked into the architecture, and it's something that I feel like you'll see in Henry's talks when we start going through the internals. So I'll turn this over to Henry.
All right. So I am just going to go with kind of rip the Band-Aid off approach and show you kind of what the Envoy's Redis proxy looks like. And the Redis proxy really evolved over time, and this is where it's in its first iteration. And it actually would be an interesting case to look at to extending Envoy as a proxy for other stateful services. So in these iterations, if we look under the hood, you can see there are a lot of boxes. So to kind of look at it, we can go from left to right. When the client makes the connections to the Envoy sidecard, first thing we see is the filter chains, where we have a decoder that is reading the binary Redis protocols from the connections, and we decode that, and it will go into the Redis filter. So the first challenge we have for doing this proxy and trying to create an illusion that we, instead of talking to a cluster of Redis nodes, create the illusion that we are really only talking to a single Redis instance is we need to actually split the command. So because a single command can span multiple keys, and those keys are actually stored in different nodes. So we need to split them to create different requests that we can then route to the correct Redis nodes. And then once we get the response, we need to also use this command splitter to aggregate them and return to the client. And next up is where we have the connection pool. This is where a lot of the interesting things that are happening as far as proxying is concerned. When we are talking about proxying to a cluster of nodes, one of the things we need to think about is actually what is the cluster? Or a very related question is how do we do service discovery? How do we discover and update the membership of this cluster? And in the first iteration, a cluster is very simple. It's a flat list of nodes that we are interested in. Then the connection pool, knowing what the hosts are, then we can start making connections and sending routing requests. So in this case, we actually can just use the out-of-the-box cluster implementations for Envoy, where we can either use DNS or XDS for cluster discovery service and in any environment. So we actually don't need to change that. The next thing, when we're talking about sending traffic to multiple nodes, is how do we distribute the different commands? And this is where the load balancer comes in. Envoy comes out of the box with a large number of load balancers, randoms, power of two, etc., etc. However, unlike a lot of other proxies where we're talking to stateless service, things like randoms or round robin actually doesn't make sense for a stateful service because we need to make sure the same key is always as much as possible routed to the same Redis node. So luckily, we have kind of the out-of-the-box consistent hashing load balancer, which is the ring hash, which is the Katama hashing algorithms that everyone's very familiar with a consistent hashing ring, or the maglev hashing. And we can, in this case, again, because our nodes are just a flat list of nodes, we can just use those out of the box. And then further up, that's where the filter chain are for upstream. So each client is thread local, so we can guarantee performance without doing any locks. And then is the reverse of our downstream, where we encode what we have understand as the Redis connections, Redis commands and requests, and then we send upstream to a Redis node somewhere. It could be in Kubernetes, it could be in your other ASGs, or yeah. And then once we get the response, we travel backwards. And of course, we also have to extend the configuration so that this can all be configured. And on top of that, we get the amazing stats framework and the admins endpoints that we can look at all the metrics and the cluster memberships. And also, out of the box, Envoy provides hot restart, and the configuration can be dynamic, meaning compared to what this was kind of inspired by the twin proxy, where we have a lot less human interactions. We don't have to take a downtime to update the configurations, etc. So this looks pretty good, but in real life, failures happen, and we need to know how to handle that failure. And in order to do that better, we want to have both passive and active health check. So for passive health check, it's actually quite simple. We just make sure whenever we get a failure in the client, that we register with the outlier detections that is provided out of the box for Envoy. But what about for active health check? How do we actually know a Redis node is actually healthy before it gets removed from the discovery? Well, we actually have to implement a Redis health checker. Again, we leverage the same Redis encoder and decoder to send either a ping or exist request to every single Redis node. So you might be wondering, like, for health check, isn't a successful ping enough? Well, actually, that is actually true. But if we use exist, we have just implement a mechanism where we can start draining traffic from a particular node before it is actually removed through the discovery service. So if we are proactively trying to replace a node, then we can put in a special key to say, hey, like, underscore drained, and then the health check would check for the existence of that drain key, and then we can use that to remove this particular node from the cluster, and then we stop routing to it. So at this point, we have a pretty well-functioning Redis proxy. It even survives network partitions, which is one of the hard things to do, because if there is a pairwise network partitions, our health checker would detect that, and it would evict it from the node, and the load will be routed to just a different node. So what more can we want? Well, if you understand the CAP theorems, you know as the number of services that use this thing increases, engineers come back and say, hey, we always want more. If you are available and you survive network partition, we want consistency. And it's a reasonable request because for some services where consistency is more important, they would rather evict the node that is having network partitions, so that everyone would always write the same key to the same Redis nodes, rather than having kind of working in a split brain situations. And secondly, when we're dealing with stateful services, sometimes having more predictable failure behavior is important. When we remove a node from a consistent hashing ring, it's not very predictable on where the shards would be landing on. And it is possible that we can have multiple hotkeys landing on a new node. And also, we want to be able to say, hey, like, exactly what the performance would look like, and if we have, which is kind of related to the next point, related to replications, is we want to be able to fall on a replica, if possible, rather than just hashing to the rest of the cluster. Also, in the last couple of years, there is really strong community support and momentum going towards embracing the Redis cluster protocols, where it supports some of these features. And what are some of the challenges of adding this? Well, prior to trying to implement this feature, Envoy's service discovery mechanism is built as part of Envoy. And obviously, we don't want to build a Redis-specific implementation into the code of Envoy. So we need to have a mechanism to extend that. And to come with the Redis cluster protocol, we have a more complicated topology, especially when we want to support things like replications. Now, we don't just have a flat list of nodes. We have primaries, and we have replicas. We have concepts of slots and shards. And another thing that will come with the Redis protocol. So the Redis protocol basically is you have a consensus, a gossip protocol on the Redis cluster itself to determine what the topology will be. And then you can make a command to it to say, hey, like, tell me what the topologies are. And if you send the request, so let's say your discovery is out of date. You send a command to the wrong node, it will give you inline redirections to say, hey, like, instead of sending this command to me, you should send it to this other node. And the challenge with that is that the other node might not be in our cluster. It might not be a node that we already know. So how do we deal with that? Well, that's what the next iteration looks like. So we implemented extensions that would handle the Redis cluster discovery. So on initializations, we would get some list of seed clusters, and then we make the Redis commands to those to call the cluster slots to get the topology. And then we use that to inform the connections. Now, on the data pipelines, when we make a request to a Redis node, and then it come back with either a ask or move, basically in redirections, then we will just resend the request to the new node. And if we are asked to redirect to a node that we are not currently aware of, then we'll create a temporary host in the connection pool, and then we'll try to drain those once they are discovered in the next time we do the discovery. One of the small trade-off of doing this is now we have to hold on to the request for longer, because in the case, like before, we get the request, we send it off, and we can clear that from the memory. But now we have to hold on until we get either an error or a failure response, because there's a chance that we need to resend that. So there is a small increase in memory footprint. So at this point, we don't need to make any changes to the load balancer. And this is what the open source Redis community call a dumb client. You could actually even use a random load balancer, because what we rely on the correctness is that doesn't matter, you send it to any Redis node, and if you get it right, it gives you the answer you want. And if it gets it wrong, it's send back a redirection to point you to the correct node. But obviously, I mean, we are working in Envoy, we don't want anything dumb, so we will find a way to get around that. So we need to create a Redis-specific load balancer that can understand this, that can handle this protocol. So it has to understand the cluster topology. It has to understand, okay, a node correlates to a shard, and then there are primaries and replicas. But also, if we are really want to send requests to replica, we can't do write requests to replica. We can only do read commands. So now we have to update our proxy to understand what is the difference between a read command and a write command. But once we can do this, we can actually open a lot of options to tune how our services use our Redis configurations. And this is actually something that is surprisingly uncommon in the current Redis client, to be able to natively say, hey, like, I want to send all of our read requests to the master only. In that case, you say, hey, like, I want to make sure I'm consistent always. I can't tolerate any inconsistency, and the replica is there only to serve as failover. Or you can say, hey, like, I want to send to the master if it's available, it's healthy, and if not, I don't want to wait for the load balancer. I just want to send the read request to replica. And similarly, if you want to protect your master, then you can route all of the traffic to the replicas. And any is just like, hey, I want to prioritize sending to any healthy host, regardless of whether they're replica or master. So what does it look like once we implement this? then we have to come up with a new mechanism for the cluster itself to provide the load balancer, rather than the load balancer being a separate configuration on the listener. And that looks pretty straightforward. The Redis cluster would update the Redis load balancer with all the shards, and it actually is, we now don't have to recompute this topology mapping. Similarly, with health check, we find that in practice, we have this dilemma. Whether if we want to have a very quick failover times when a node fails or when we add a node, we have to have very short, if we only rely on periodic updates, we have to have a really short refresh cycle. Like we would be pinging the Redis cluster for topology update all the time. Or we have to tolerate a long period of increased redirections. Surely we can do better. And that's when we introduce this Redirection Manager. So whenever we get the redirections, we tell the Redirection Manager, hey, we're receiving the redirections. This is probably a good idea to trigger a topology update and update what our cluster should look like. And we also use the Redirection Manager to protect the cluster so that we can say, hey, like, you can't keep sending topology update. You can do it once every 10 seconds or something like that. So this is actually pretty feature complete as far as proxy against a single cluster is concerned. But then when we start using it more, we find that we have a lot of scenarios where we actually want to involve multiple clusters. We want to be able to mirror to multiple clusters, maybe cross regions. Or maybe we want to have Envoy manage where all these commands go. Like we can have a shared cluster with different prefix, and then we can route them just like how we route HTTP requests. And so we added this router where we can route a request not just on what nodes in the cluster, but across multiple clusters. And Nico is going to talk about a very interesting case where we use this.
Thanks, Henry. So over the last year, we've done all this hard work, and the real-world application is migrating millions of QPS to Redis Cluster at Lyft. We have hundreds of clusters, something like 40 million QPS or more during peak or during load tests. The biggest cluster is 500 nodes with a quarter of that whole load. These clusters aren't all just straight up caches. Some of them are more like transient data where there's a source of record and you can't just throw away the data and rehydrate from Dynamo, let's say. And these services are in Python, Go, lots of different languages. And like Henry was saying about Redis clients, each language kind of has its own implementation. And with Redis Cluster, where you have a smart client, this becomes really critical because you want your topology updates to be the same. You want a lot of that behavior to be consistent. So how do we migrate all these things? Zero planned downtime, zero outages, zero data loss. How do we do that? And the answer, of course, is Envoy, as you guessed. Traditionally, Redis migration has been really painful. You look across all the applications that might be using a given Redis cluster and like a regular Redis, not just Redis cluster, and instrument everything, dual write. If things look all right, then you dual read, and then you kind of hope. And if you're lucky, it works well. Otherwise, you need to go back and monitor Redis, check where all the connections are coming from. And with Envoy, you don't need to do this anymore. You can really kind of know where everything's going. If you're already talking to Redis via Envoy, you have consistent stats. You don't need to make any changes to the application with our cluster support. You don't need to use a cluster Redis client. That's really the key part. Because you'll have now consistent behavior across everything, Envoy manages topology. With the stats, one thing I wanted to call out is that because you can get stats in the upstream, not just the downstream, right? Can traditionally just look at your downstream stats, but if you have multiple upstreams where you're mirroring cross traffic, You can just get kind of individual per upstream request stats, and then we also have some special Redis command stats, so you can get kind of per command counts and really get more confidence that things are all in sync. And then, finally, you can mirror the traffic from one Redis to another. And like Henry was talking about, we have prefix routing, which, if you have unique prefixes, allows you to compose and decompose traffic from different services, which becomes very powerful later on. So let's now talk about how a migration looks. Practically speaking, it's a 4-step process. If we have a single service that talks to Redis via Envoy, like we do at Lyft, it's really straightforward. Assuming you've provisioned your new Redis, you'll then just add the Redis in the cluster section of Envoy config. And immediately you'll start to see health checks come in. If you go in Redis and monitor the connections, you'll see the connections. And you don't have to add a listener for the new Redis. If you want to, you could, just to make sure things are up and running. But this was enough to get you started. The next step is adding a mirror policy. So this is where we essentially just tell it, you can shift this, or you can copy this much traffic over to the new Redis. And it's useful not just for, warming the cache, but also load testing and sizing. And it's pretty performant. For that one big cluster I mentioned, at peak of load test, we're something like 23 million queries per second across 1,000 plus service nodes, I think. And there was no degradation in performance. That was really great. And then, monitoring, we have our upstream stats on both sides. And then we essentially can mirror for a while. Our max TTL, we might want to bake a little bit longer if we have a new computer environment, like if we're moving to Kubernetes or a new cloud provider. And then once we're there, we can validate our data. So for Lyft migrations, we've chosen to essentially just, say, given a Redis shard in our old Redis, let's get all the keys, and then run those keys through Envoy for old and new, and compare them by data type. And if we have under a certain threshold differences, we're good. Now, mirroring has one case where it won't work, and this is if you have data that doesn't have a TTL, like you're using Redis as a queue. So, there you need to do some sort of copying. So finally, you can essentially switch over traffic. Now, one thing I want to note in this diagram up here is that we do a reverse mirror to keep the data in sync on the old Redis, so we can bake, especially if we're moving like to Elasticache or a new environment, just let it sit for a while and we can switch back in an emergency. The other point here to note is that we're not doing a selective read really like you might do normally. We're just in the listener, we'll just say, pointer to new cluster and then change your mirror policy to pointer to old cluster. But we've been reading and writing to both clusters the whole time, so it's not really that different. We have stats that basically show everything's working, and then we've done our validation. And, then we bake a little bit longer, and we get ready to turn off all the Redis, and then we do that. We've done this for a number of Lyft services, and it's worked pretty well. And we've done tens of clusters, millions of QPS, and we haven't had an outage yet. It makes me very happy. So finally, what's next? We'd like to support some more commands. We'd like to support new data structures like streaming. We wanted to implement fault injection next year. The HTTP side of Envoy has this, but Redis does not. With Chaos Monkey, we can kill a node, but we really want to have more fine-grained control. We also want to do stuff like add consistent retries across all of our Redis users, just like you have with the stats. And then we'd like to add rate limiting and finally compression when people start storing big blobs. So that's it. I think we have I don't know if we have enough time for Q&A here. We only have about a minute left. We're all hiring. Come and grab us if you have any questions.